Let's talk about solving a system of equations by graphing. Now, this is the foundation of solving systems of equations. So we're going to go through how to solve by graphing, but usually when you're solving a system of equations, you're not going to actually use this method. It's not super precise, but you can kind of get a ballpark of where your answer is going to be. And it's also, like I said, the foundation of solving systems of equations. So a system of equations is two or more equations, and you're trying to find the values that work for both equations. When I look at this system of equations, you can see that they're both linear equations. They're both in the form y equals mx plus b, where m is my slope and b is my y-intercept. When you're solving a system of equations, what you're doing is you are finding the ordered pair that works for both of your graphs because it is the place where your two graphs cross. So let's say these are the graphs of the equations that I'm given, then my solution is going to be the one point that they have in common, or it's going to be the point where they cross. Now, these are not the graphs for my equation, so let me go ahead and back up and we will do these graphs. First, I'll sketch myself a coordinate plane and then we'll go through and we'll find our slope and our y-intercept to graph. Okay, my first equation, I will do this one in red. So that's going to be y is 2x minus 4. My y-intercept is where we always want to start when we're graphing linear equations. And here it's -4. So I just go down 4 and put that y-intercept on my graph. Then my slope is 2, and we want to write slope as a fraction, so 2 over 1. When you're graphing your slope, we use rise over run. So the numerator 2 tells me how much to go up or down. It's positive, so I go up 2, and then over to the right 1 because the denominator is positive 1. And I'll do this a few times because I'm not sure where my graphs are going to cross. So I want to make sure that I have enough information to be able to find where my graphs cross. So I will connect and draw my line. So more or less my line looks like this. My second equation, y is -5x plus 3. Again, I'm going to start with that y-intercept of 3. So I go straight up 3 on the y-axis, put my y-intercept, and then my slope is next. -5 or -5 over 1, which means down 5, right 1. So counting from that y-intercept down 1, 2, 3, 4, 5, right 1, you can see the point where they cross is where I just put that next point. Connect my dots, and there is my second line. So the solution that I'm looking for is, again, that point where the two lines cross. So this point right here, which looks like 1, -2. Now we should definitely check, because when you're graphing, if your graph is a little bit sloppy, maybe like mine, I hand drew it so it's not perfect, I'm not totally guaranteed that this is the actual answer. Maybe I'm off by a couple decimal points. So let me take these, plug them back in, that way I'm totally confident that I have the actual right answer. My first equation, I will plug in my -2 for y and then the 1 for x and verify that everything checks out. -2 equals 2 minus 4, -2 equals -2. Yeah, that worked out. I ended up getting a true statement. My second equation, I'm going to do the same thing. So that one worked out as well. So I'm pretty confident that my solution is 1, -2. So this is a solution to my system, meaning it is the point on the graph where the two lines cross. Hope that helped. Thanks for watching, and I will see you next time. Bye.